Okay, hello everybody, what's going on? My name is Mohammed. I'm going to teach you today how to solve for this problem. So the problem is that we have the logarithm of 5y base x equals to the logarithm of 5x base y, where x is not equal to y. And the question is asking us to solve for xy, for the product xy. Okay, so one way to think about this is to rewrite to use the laws of logarithms in order to rewrite the left-hand side and the right-hand side so that we can come up with a quadratic equation in logarithm of y base x, and then we can solve for the product of xy. So to do that, so let's do that. Okay, so first of all, I will rewrite the left-hand side as the logarithm of 5 base x plus the logarithm of y base x, and that's going to be equal to the right hand side, which can be rewritten as the logarithm of 5 base y plus the logarithm of x base y. Now we can notice here, guys, that the right hand, these two terms here on the right hand side can be rewritten in terms of logarithm of y base x. Okay, so let's do that. So this is going to be equal to this is going to be equal to the logarithm of 5 base x divided by the logarithm of y base x. And of course, the other term can be rewritten in the same way as logarithm of x base x divided by the logarithm of y base x. And we can notice, guys, here that this term here is equal to 1, of course. So basically, that's the reciprocal here. Okay, and then we can notice that these sides here, these sides here, and this side here, and also this side here are the same. So basically what we can do here, we can multiply everything by logarithm of y base x. Okay, so let's do that. Okay, so if we do that, that's going to give us logarithm of 5 base x multiplied by logarithm of y base x plus the logarithm of y base x, and that's going to be raised to the power of 2, so that's going to be squared, and which is equal to logarithm of 5 base x plus logarithm of x base x. And then we can reorder the terms. We can move the right hand side to the left hand side and make everything equal to 0. So let's do that. And you can notice that we can get a quadratic equation in terms of logarithm of y base x. So first of all, I will start with the quadratic term, which is logarithm of y base x, and that's going to be the squared term. Okay. Sorry. Plus, and then we can move the logarithm of x base x, so that would give us minus logarithm of x base x here, plus logarithm of 5 base x multiplied by logarithm of y base x minus logarithm of 5 base x equals to 0. Now, if you guys can notice, we can, let me use another color here. We can notice that we have a common, factor here that can be taken as a common factor, okay? And also we can notice that this term here, we can force this term, to be raised to the power of 2 because it's 1. So if we raise that to the power of 2, that wouldn't change its value because it's already 1. So let's do that. Why are we doing this? Because we want to get or benefit from the fact that we have here difference of 2 squares, okay? Which is basically this term and this term. This is a difference of 2 squares, so we can factorize that using the difference of 2 squares. And we can take here this as a common factor. So let's do that. Okay, so first of all, I will, this is going to be equal to the logarithm of 5 base x plus logarithm of x base x multiplied by, of course, the logarithm of y base x minus logarithm of x base x. Okay? And then I can take the logarithm of 5 as a common, of 5 base x, of 5 base x as a common factor. And what we're going to be left out with is the logarithm of y base x minus 1, which can be rewritten as logarithm of x base x. And let me move this here. Okay, and let me close the parenthesis. And all of that is going to be equal to 0. Okay, now looking at this term, we notice, guys, that this term here, this whole term, is exactly the same as this term here. So this can be taken as a common factor as well. Of course, we can notice as well that this term here can be rewritten as logarithm of xy base x, because the two logarithms are added to each other. And of course, this second term here can be rewritten as logarithm of x of y divided by x for the same exact reason, and plus logarithm of 5 divided by x multiplied by logarithm of x of y divided by x equals to 0. Now we can go ahead and take this as a common factor. Okay, so let's do that. So logarithm of y divided by x base x equals to, if we can take that as a common factor, then we're going to be left out with the logarithm of xy base x plus logarithm of 5 base x, and we can close the brackets, and that is going to be equal to 0. Now for this final term here to be equal to 0, then either the first term is equal to 0 or the second term is equal to 0. So that means that the first term, logarithm of y divided by x base x, is equal to 0. And that means that y divided by x is equal to 1. And that means that y is equal to x. And this is basically ignored. Why? Because since x is not equal to y as per the information given in the question. Okay, if we go back, it says here x is not equal to y. So this solution here is ignored or is neglected. Okay, or the second solution to this problem is that the second term here, logarithm of xy base x plus logarithm of 5 base x is equal to 0, and that means that logarithm of x y base x is equal to minus logarithm of 5 base x, which can be also rewritten as logarithm of 1 by 5, which is 5 to the power minus 1, which is 1/5 base x. And for these two logarithms to be equal to each other, that means that the product xy is basically equal to 1/5, and that is basically the solution to this problem. Okay, so if you like this video, hit like, and don't forget to subscribe to the channel and click the bell so you don't miss anything. Thank you for watching, and see you in another video.